In this section, we'd like to write the equations of motion of the two objects. First object of the m sub 1, position vector of the object m sub 1 has r sub 1, this one, and m sub 2 has a position vector of the r sub 2. Then relative vectors between the m sub 1 and m sub 2 is these vectors can be expressed sum of the two vectors, this plus this vectors. This vector is minus r sub 1 vectors, so r sub 2 vectors. So this relative vector r can be expressed r sub 2 minus r sub 1 vectors. Then the unit vector is directed toward the parallel to the r vectors, these unit vectors. Is expressed r vectors divided the magnitude of r. Then we can create a unit vectors parallel to the r vectors. Then universal law of gravitation would like to express in the vector forms. So these equations actually is equal to the g m sub 1 m sub 2 over r squared r vector over r. These factors correspond to unit vectors. Then magnitude of the universal law of gravitation give the this ones. And then from the Newton's second laws, F sub 1 and F sub 2 is the opposite directions with the same magnitude. Then we apply the Newton's law is a mass times accelerations is equal to the force. And the mass times acceleration. This is acceleration, a sub 1. This is a sub 2. Mass times acceleration is a force, Newton's laws. Then you can substitute F sub 1 and F sub 2 here, and then you will get equation of motion for the two objects, m sub 1, r sub 1, 2 dot. Dot means is a derivative with respect to times. So this is equal to dr sub 1, actually second derivatives. Okay, then substitute f sub 1 is here. Okay, this is the equations of motions. Now we'd like to change the variables. So now we have a r sub 1 and r sub 2 is a variables. To the actually r, capital R, and R relative vectors. So we'd like to change the variables of variables. And R vectors, capital R is expressed as these ones. And the lower case of the r is expressed this one. From the r sub 1 and r sub 2 to the capital R and the lower case of the r is the change of the variables. Then we still writing the equation of motion. Then if you sum up these two equations, this is exactly equal magnitude, but the opposite direction of the vectors is negative sign. If this sum it becomes 0, and the left hand side it becomes sum of these two. Then actually this left hand side is equal to the second derivative of this quantity times m sub 1 m sub 2. If you consider the first derivative of the r, look at this equation, it becomes r dot equal m sub 1 r sub 1 dot, because m sub 1 is constant, and m sub 2 r sub 2 dot. And the second derivatives, one more dot is added. So this is exactly equal to this one. Then from this equation, r sub 2 dot is 0. So this means r sub 2 dot is 0. This means d dt r dot is 0. Then inside of the parentheses have to be the constant. So r dot, capital R dot have to be the constant. So this means position vector of a center of mass move with a constant velocity. So we could solve the equation for the center of mass. Okay, then we'd like to move to the next practice. Practice 2.2. Calculate the distance between the center of the Earth and the center of mass of the Earth and the moons. Compare the distance with the radius of the Earth. This is the practice 2.2. Then we'd like to write down the figures at first. The Earth and the moons. Position vector of the center of mass is expressed m sub 1 r sub 1 plus m sub 2 r sub 2 over m sub 1 plus m sub 2. So in this case, we choose the origin is located somewhere here, for example. But we are free to choose the origins. So you can choose the origin is exactly located at the center of the Earth. This is origin. Then what happens? Actually, the r sub 1 becomes 0. So you can substitute r sub 1 is 0. So this means m sub 2 over m sub 1 plus m sub 2 r sub 2. So this is equal to the r sub 2. The magnitude, if you consider magnitude of the r is equal to the m sub 2 over m sub 1 plus m sub 2 r sub 2. Then you can substitute mass of the moons and mass of the Earth. Then you will get 4.6 times 10 to 3, 4,600 kilometers. The radius of the Earth is 6,400 kilometers. So center of mass is located somewhere here. The center of mass is located inside of the Earth. We would say the moon is a satellite of the Earth because the Earth is much heavier than the mass of the moons. The center of mass is included inside of the Earth. Then we'd like to move to the next topic of the relative position vectors. So we have already find for the equation for the position vectors of the center of mass. Then we'd like to find the relative position vectors for the R equation. Again, we'd like to start with these equation of motions. Then derive the equation for the relative motion. Should be expressed this way. So this is a practice. Derive the equation of the relative motion. This equation of the motion for two bodies are given by these two equations. And I'd like to show you how to get this equation. So from the first equations, maybe I should write m sub 1, r sub 1, 2 dot equal g m sub 1, m sub 2 over r cube r. If you divide the m sub 1 in the both sides, r sub 1 2 dot equal g m sub 2 over r cube r. And the m sub 2 r sub 2 2 dot, the other equation is negative g m sub 1 m sub 2 over r cube r. From this equation, if divided by the m sub 2, r sub 2 2 dot equal minus g m sub 1 over r cube r. Then r relative vectors, relative position vector is expressed r sub 2 minus r sub 1. So this means r2 dot equal r sub 2 2 dot minus r sub 1 2 dot. Then you can substitute this here. Then it becomes minus g m sub 1 m sub 2 over r cube r vectors. This is gonna be the end of the equations, but it might be better to express the force acting between the two objects in the universal law of gravitational force, like a g m sub 1 m sub 2 over r cube r. So this is a universal law of gravitation. Then you have to multiply the product of the two masses. So we have to multiply the m sub 1 m sub 2 in the left hand side as well, and divide it by sum of the two masses. So it should be the m sub 1 and m sub 2 r 2 dot. And then we name it. This is a mu. This is reduced mass. Okay, so finally we have equations for the mu r2 dot is a minus g gravitational force acting between the two objects is expressed in the universal law of gravitation. So in this case, we change the variables from the r sub 1 and r sub 2, and the mass is changing to the mu, is a reduced mass. Okay, so equation of the relative motion is expressed mu r2 dot equal minus g m sub 1 m sub 2 over r cube r vectors. So number of the equations we need to solve become the 3's, because we have already solved the equation of motions for the center of mass. So we used to have r sub 1 is a 3 component, and r sub 2 is a 3 component. Its total number of the component is 6. But now we have already solved the r, capital R, 3 component. So lowercase of the 3 relative position vectors we need to solve 3. So number of the equation is significantly reduced by the change of the variables. So this is the end of this sessions.